Great. So I'm going to hand over to our next speaker from Bentley Systems, Todd Roberts, who's going to be presenting on US digital twin models. And I encourage everyone, if you have any questions, please do post them in Mentimeter. We'll be getting to those after Todd's presentation. So Todd, over to you, please.
Thank you, Simon. Thank you, everybody, for having me join the call this morning. I'm going to share my screen here. Have some introductory slides to introduce the story. Are you guys able to see my screen?
Yes, it's just come through.
So we're going to talk about digital twins, of course, but we're going to talk specifically about how IoT can breathe life into a digital twin environment, and just have some graphics to go with this here to tell the story. I think for many people in our industry, IoT or monitoring applications can be a very simple workflow, but for many others, it's very abstract and complex in nature. And when you look at a digital twin, how do we collapse that complexity to establish field to office, back to field workflows using sensors, using IoT, Internet of Things devices? Things that have to be considered are the ease of integration. How do you actually establish connections that get data from the field into the office, and then from the office into the digital twin? That has to be interoperable in nature to be effective. How do we visualize that information and make it available to a larger audience? And then how do we update the data sets in real time that may be beyond what is in a digital twin from IoT perspective, but it might be other structures or emergency response applications. And then again, that's how do you go from an engineering base, albeit a hyper-focused engineering geotechnical structural focus, into a larger audience to reach city planners, architects, others that may not be IoT specialists. Well, first you have to understand that IoT is not a new thing. The word IoT might be new or newer in use, but ultimately monitoring applications have been around for many decades. And I think some of the first sensors go back to the 1940s in France, where some piezometers were used to monitor dams. But ultimately, sensors and monitoring applications, or now IoT, is used in water resources. So you can be thinking of water storage or hydroelectric applications, and mining, open pits and tailings facilities. Transportation's prevalent globally: bridges, rail, road, tunnels applications. Construction projects, albeit short-term in nature, commonly use monitoring to keep nearby and adjacent assets safe and secure during construction activities. And then energy is starting to make use of monitoring applications. So it's the sensors are largely in place or required in some applications, but how do we get them into a workflow that can be used within a digital twin? Well, the story has to start with understanding the different types of data that are being collected. Some of them are manually collected. Some of them are enterprise systems or SCADA systems that have been in play for decades. Other devices are using IoT hubs or IoT devices that are making the data available in different frequencies, different reading time frames, or different collection methods. But all that data has to coalesce within a platform to be then made available into a digital twin experience. The concept is, take any city environment where you have a different assets from different industry perspectives. We digitize those assets and then enable them with IoT devices, sensor devices, to breathe life into them, to make the digital twin become alive and actionable, and something that can be updated by the minute, by the hour, rather than by the day or the quarter or by the year, by other data set ingestion. So for Bentley and other applications that are being built globally by many vendors, the concept is there's engineering information that becomes relevant. There's operations level documentation, IoT feeds like we're talking about here, cameras, LiDAR, and then there's asset performance, where you have asset tagging, maintenance records, inspection records that have to land on a digital twin that needs visualization information as well. So you might be using immersive environments where you're using 3D applications. You're considering the 4D time domain of the twin, and then maybe you're engaging with AI and machine learning and predictive analytics all mixed together and into the project level digital twin. So now I'm going to switch over to give you guys an example of a working digital twin. This is a rail application. It's a rail station. Both the subsurface elements and the actual structure itself are depicted here in view. And then there are many layers within this document, this digital twin, that will allow you to engage in whatever experience you want to have as a user. There may be engineers looking at this, or maybe architects, maybe construction managers, maybe city and urban planners. There may be rail maintenance right-of-way guys that are looking at this asset, and how do they make use of a digital twin to quickly understand the status of this asset. And by associating sensors at certain critical elements of the twin, we're able to quickly just depict, is this structure tilting? Maybe we can look at another sensor here, zoom out. And this one here is a temperature sensor, and you're looking at an alert that's been tripped. That's why it's orange as a status indicator. And you can see a trending increase in temperature, albeit it's diurnal, but it's exceeded some threshold. And the concept here isn't to look at just one particular sensor, but to make all this information available in a twin environment so that a larger audience can make use of information in a holistic, in a unified way, an approach of having all the information coexisting. And this is a very high level, just little slide deck of how digital twins can make use of IoT data. And that's my short little presentation, but welcome any questions that may be coming in.